This is the Building Automation Monthly Podcast with Phil Zito, episode 186. Hey folks, Phil Zito here, and welcome to episode 186 of the Building Automation Monthly Podcast. In this episode, we are going to be talking about 100% outdoor air units and makeup air units, and we're also going to be talking a little bit about mixed air temperature control. So this is, I believe, the fourth episode in our multi-part series on HVAC sequencing. And this episode is brought to you by our HVAC Control Sequences course. If you need to learn about HVAC in order to be successful in your building automation career, which that is a given, you do need to know HVAC in order to control, install, program, service, sell, and support control systems, then you probably are thinking, hey, how do I go about learning HVAC? Well, one of the ways you can do that is going through a multi-year trade school and becoming a mechanic. But for a lot of controls technicians, that's overkill. What our Control Sequences course does is it teaches you everything you need to know about how to control mechanical systems with your building automation system completely online in the shortest amount of time possible. This is one of our most popular courses because it teaches you everything you need to know about controls theory, systems knowledge, and how systems work. I encourage you to learn more about the course by going to buildingautomationmonthly.com/186. All right, folks, one more announcement. If you're listening to this episode on the week of Thanksgiving 2019, our 25% off course sale that happens every Black Friday to Cyber Monday is going to be occurring, and you can purchase any of our single access courses for 25% off their price by entering the code BF2019. That's Bravo Foxtrot 2019 in the coupon code area for any of our courses. Now, this is only valid from Black Friday to the end of Cyber Monday of Thanksgiving. So definitely take advantage of that. It's one opportunity for you to purchase our courses at a potentially lower price for you. All right, so let's dive into the topics. In previous episodes, we talked about space control, we talked about air handlers, we talked about fan coils, we talked about rooftop units, we talked about mixed air, single path, variable, and constant volume units, and now we're looking at closing out the air side. One thing I want to talk about that we didn't really get to finish up in the previous episode was mixed air control. We talked about it briefly, but not a whole lot. Now, we talked about how there are low temp alarms, and that when it's triggered, that will put you in a low temp state. Something I really want you to think about as you move through any of these sequences is a state-based mindset. So where I see a lot of folks get in trouble, especially with the air side stuff, not so much with the hydronic, but very much with the air side stuff, is not understanding state-based thinking. So when you think of an air handler, you can be in a cooling state, you can be in a heating state, you can be in a ventilation state, you can be in a dehumidification state, a rehumidification state. There's multiple different states. And what I want you to think about when you think about states is, what state am I in? What parameters would trigger me to be in that state? And then what should be happening in that state? This will really help you program. This will also really help you troubleshoot. So for example, if you're in a dehumidification state because your return air humidification or humidity level or your space humidity level is too high, then you can expect your control system to potentially be doing simultaneous heating and cooling. You can also expect that you're going to be trying to drive the air to saturation. That way you can then drain out the moisture and then heat the air back up prior to sending it downstream. That's how typical dehumidification sequences work. So when we think about our low temp and our mixed air control, there's several different variables that can take place. We have low temp control, which is where the airstream incoming is too cold and you don't want to freeze coils. So you start to close outside air dampers where most of the cold air is coming from. You start to open up preheat valves if they exist and reheat valves if they exist to full position. You close cooling valves typically and you run the fan. And that's what you'll typically do in order to make sure that you don't freeze coils and everything's all well and good. But there's also mixed air temp control, in which we are either using a preheat or we are using a outdoor air damper. And I see a lot of folks mix this up because what they don't realize is that there is both a heating component typically and a cooling component to mixed air control. The cooling component to mixed air control is typically using your economizer to drive your mixed air temp down. So you've got a mixed air temp set point, you've got a mixed air temp, and you're opening up your economizer to bring in cold air to drive the temperature down. You also, though, have preheat, which typically will come before the averaging mixed air temp sensor, and you will drive a preheat valve open in order to go and condition air. Now, you will sometimes see this on mixed air single path units, but you will especially see this as we move into our 100% outdoor air unit sequences. So let's take a look. I'm going to go through our 100% outdoor air sequence that I have here in front of me, and we're going to start to go through it. And the sequence has the basic safeties you would expect: high-low static, smoke and fire detection. But it also, and it also has, freeze stat, high, low, humidity, those kind of things. But it also has an outdoor air damper status. This is really important when we're using 100% outdoor air units, because that fan needs to draw air from somewhere. And if you don't have a 100% outdoor air damper open, then the outdoor air damper is not going to be providing airflow, and that airflow then is not going to get inside the unit, and the unit's going to start to suck in the sheet metal. I've seen this happen. This is kind of the inverse of if you had fire isolation dampers downstream from a fan, and those were closed, and that supply fan was blowing air, and that air had nowhere to go, so it would pop the ductwork. Well, this would suck in the ductwork. So we need to be cognizant of that. Our outdoor air dampers are open upon our fan signal to start. And if the fan doesn't start, then the dampers are going to close, and we're going to have a fan failure alarm. But if we don't get damper status, then we are going to actually go and turn off the fan, because that is one of our biggest issues. Now, it's all well and good to have a damper status, but sometimes those damper statuses can fail. There's a bunch of issues that could potentially occur that could cause us to have no damper open, even though we have status saying it is open. That's why we always typically want to have a low static pressure safety cutoff. And that low static pressure safety cutoff is going to make sure that, hey, if our static starts to drop too low, that meaning that we have an issue with our fan and the damper most likely being closed, we then will shut off the fan. So that's kind of our safety there. Then on these outdoor air units, what we will tend to have is both preheat, cooling, and reheat. We tend to see these outdoor air units used where we can't recycle air. So something like an operating room where you constantly want fresh air, you don't want recycled air, or maybe a containment room, or maybe an area where you're dealing with electronics and you really want to deal with the quality of air. In this scenario, we will often have cooling valves, we'll have preheat valves, we'll have potentially a humidifier, and we will also have reheat. So fan speed control is hit or miss with 100% outdoor air. You're either going to have constant volume or you're going to have variable volume. Now, we can have variable volume with 100% outdoor air units, especially if we're serving operating rooms that have a supply box and an exhaust box in the operating room, and they are trying to manage a positive pressure scenario in the OR so that nothing can come in, right? We're pushing all the air out. And in that case, we would typically have a VAV in the operating rooms, and then we'd have VFDs on the 100% outdoor air unit in order to drive the discharge static pressure so that these VAV units can properly supply flow. And what we would typically have interlocked with these units, especially if we have variable return air return boxes, is we would have a exhaust fan interlocked, not part of the unit, but interlocked with the operation of the unit. And that's how we're going to go and make sure that we are varying our exhaust to either do our volumetric offset or just to maintain positive pressure. Most times we're going to be looking at space pressure and maintaining that. Sometimes we'll do it through a volumetric offset. Most of the time, like I said, we'll have like a TSI monitor that will measure pressure of outside the space and inside the space, and will maintain a positive pressure scenario. All right. So that's fan speed control and pressure control. Cooling valve, pretty straightforward, right? We're going to go and drive that to a discharge air set point. Now, typically what we will do is we will drive a discharge air set point, and we will drive it to maybe like 55, 53, 52 degrees, depending on, our humidity projections and at which point we're going to reach saturation and have the effect of draining the humidity out of the airstream to the point where we're at our relative humidity goal that we want when we reheat the air. Because the air is typically going to be reheated by the boxes within the space. Now, we also have a preheat control. Now, this typically is solely existing to preheat the outdoor air airstream as it enters the space. So you may see steam preheat in scenarios where you have to use 100% outdoor air unit, but the outdoor air is really, really cold and you want to be able to overcome that airstream. So you'll see steam, which is capable of introducing a massive amount of BTUs into the airstream rather quickly. The one thing you have to worry about, though, is if the outdoor air is really low relative humidity already, and you reheat that airstream with your preheat, you're going to have a humidifier to add moisture back to the airstream, because remember, with psychrometrics, we are going to already be at a pretty low amount of moisture as the temperature gets lower. So even like a 30, 50, 60% relative humidity is going to have much less moisture at 0 degrees outdoor air than it is at 70 degrees outdoor air, just due to hotter air being able to contain more moisture content. So what's going to happen is we're going to have this preheat, and especially if we use steam and we really heat it up really fast, one, we're going to want to have really tight control, 1/3, 2/3 valves, to make sure that we're controlling our steam and we're not overheating the airstream. But two, we're going to want to make sure that we are introducing humidity after this, because we're going to bring that temperature up, and most likely that relative humidity is going to drop substantially. Which brings up humidification control. Typically, we are going to have a humidifier, and that is going to go and either look at the space temp and determine the average humidity there, and we're going to drive humidity based on, or not space temp, the space sensors, and drive space humidity, or we are going to drive it off of the actual airstream itself. It's hit or miss. See, the thing is, if you're doing your sequencing of your supply and exhaust boxes right, and you don't have a whole lot of things introducing moisture into those spaces because you're properly pressurized, then really you can control humidity at the airstream level, at the supply airstream, and be pretty good. The reason I tend to avoid averaging is that you could have swings if you're not properly pressurized. However, with averaging, you can also use that as well and just say, hey, we're properly pressurized, our spaces are going to be pretty tight on humidity, and we're going to use an averaging scenario where we look at the average relative humidity and then drive that as our set point for our supply airstream, and we can do that. Another thing we can do that I see very commonly is resetting based off average. So that's another scenario. So I'm giving you a lot of scenarios. I'm not necessarily telling you which one is my preferred. But like I said, there's a static set point for the supply airstream. There's looking at the average value across the spaces and using that for the supply set point. And then there's resetting, where maybe you take like a 60% relative humidity average, and that, or 60% relative humidity setting, and that is when you're at 45 average, and then you can do like a setting of 85 when you're at 30% relative humidity space average. This also can be used you can use this as a kind of linear scaling reset like we do with hot water supply temp, or you can do maybe like a trim and response, which we do with pressure, where every 5-10 minutes we adjust the set point up. That's really up to whoever writes the sequence. It's also up to you depending on how tight you want the control, how responsive you want the control. So, I gave you 4 different scenarios, right? I gave you just a static set point for relative humidity. I gave you matching whatever the average is. I also gave you a reset scenario that's linear, and I gave you a reset scenario that is trim and response. I really hope at this point in the episode, and by the way, folks, if you haven't listened to the past 4 episodes, I really encourage you to, because these episodes build upon one another, and I'm starting to go into more advanced sequencing and controls theory and things like that. So it's my hope that at this point in the episode, in the series, that this terminology that I'm utilizing is familiar to you. I know I'm talking really fast because I'm trying to cram a lot into 30 minutes, but I also want you to be comfortable in that you're taking this information in and you're really starting to understand kind of the theory behind all of these control sequences that we're enacting. All right, so that's pretty much it for a 100% outdoor air unit. Sometimes for 100% outdoor air units, you'll have an ERV, which is it's like an energy recovery unit, and what it is, it could either be for humidity or for BTUs, and you have this wheel that will then, and for humidity, it's typically a wheel with decusant on it and or some other chemical, and it will reclaim moisture and then reintroduce moisture into the airstream, or remove moisture and introduce it to the exhaust airstream, just depending on what you're sequencing. But there's also where you could have heat pipe, where you have a set of coils in the incoming airstream and on the outgoing airstream, and basically you'll take some of the heat on the exhaust airstream during a cold scenario, and you will take that heat and transfer it to the incoming outdoor air airstream, thus heating up the air. That outdoor airstream will absorb the heat, and it'll transfer now that chilled water back to, or chilled glycol, back to the exhaust stream, which then will once again absorb heat from the exhaust stream. And that's kind of an energy recovery scenario that you may see in a 100% outdoor air unit. So that's that. Next up, we have mixed air units, okay? Or mixed air units, makeup air units. I always want to call them mixed air units, MAUs, but I know they're not called that. It's just so freaking tempting. But makeup air units are pretty straightforward, at least on the surface level. They can get complicated. You gotta forgive me here if I'm like snorting and making noises. I've getting over a head cold here, and it's like, oh my goodness. I went recently to Disney World with my kids for 8 days, and I managed to avoid my 8-year-old, who was like really sick, like nastily sick. And I managed to avoid it all the way up to the last day. And on the last day, she finally broke my immune system and got me sick. And now I got a head cold. So that's freaking awesome, right? Right on Thanksgiving. But anywho, so forgive me if I'm like coughing and making noises. But with that being said, so makeup air units, you'll see these a lot in high rises. You'll see these a lot in kitchens. You'll see these a lot in buildings where you're exhausting airflow, and you need to make up airflow into the space. Now, there's kind of 2 ways of makeup air units. You can have makeup air units that precondition air and pipe it into the building, or you can have makeup air units that just supply air into the building or into the airstream. It's kind of 2 different ways. In a lot of hotels, in a lot of apartments or high rises, you'll see makeup air units used for the corridors, and then you'll see mixed air single path units with VAV units utilized for the spaces. And the whole point of a makeup air unit is simply as the air is exhausted out of the space to kind of repressurize the space or building so that you maintain positive pressure. You'll also see these in kitchens where you have a dedicated kitchen exhaust and you're using a makeup air unit that is running in parallel. Makeup air units, they have a lot of different things going for them, right? You can have just pure makeup air units with just a fan and an outdoor air damper, and it's bringing in air at a static CFM value, and that is balanced so that it pressurizes the building. Then on the complete flip side, you have makeup air units which are variable, which have mixed air returns, which have face and bypass dampers, which is something we haven't really talked about here yet. So let's start to kind of unpack the most complicated, and then we'll go from there. So with face and bypass, what that is you have a damper that faces the coil and a damper that bypasses the coil. So bypassing would just straight up continue the airstream through this kind of little dip. Typically, it'll go either up or down, and it'll be a bank of dampers. Top one will open up and will face the coil and allow you to go through the coil. Sometimes it's the bottom one that will face the coil. It just depends how the unit's built. And then the bypass damper, whichever damper that is, that opens up to bypass the coil. Typically, it'll either be a cooling or a heating coil. And so when you need to control discharge air temp, you will face the coil and pass it through. And when you need to not control discharge air temp, you'll bypass the coil. Pretty straightforward, right? So makeup air units. And then the whole 100% outdoor air damper versus a mixed damper. It all depends on what you're using the makeup air unit for. If you're using it for making up pure fresh air, which a lot of scenarios are, then you'll typically have a pure 100% outdoor air damper and you will pull through that. If you're using this as a kind of mixed air solution and you don't really care about the 100% outdoor air, you don't care about meeting ASHRAE 62 requirements, you're not using this for that purpose, in that case you can have a mixed air damper and it'll just open, typically based on controlling the mixed air temp. So there you go, folks. Managed to keep this down to 20 minutes, and with that we're pretty much done with the air side of things. And in next week's episode we're going to start to look at chilled water systems. We're primarily going to focus in on air cooled. We may get into water cooled chilled water systems as well. As I mentioned, don't miss out on our building automation Black Friday through Cyber Monday sale using the code Bravo Foxtrot 2019. That's BF 2019. You can find out more about that by going to buildingautomationmonthly.com/186. Thanks a ton. Take care.